Hi everyone, and welcome back. So today we're going to take a look at probability of compound events. This is page 482 in the textbook. So go ahead and put your name up at the top, your class hour, and today's date. All right, let's take a look at the objectives for today. So we're going to find the number of outcomes of an event. Find the number of outcomes for an event. And we're also going to find the probability of a compound event. Find the probability of a compound event. All right, so last time we looked at, 2 times ago, we looked at simple events, which is when one time, like something happened just once. So now we're going to look at compound events, meaning multiple times something could happen. So we could end up taking marbles out 3 or 4 times, or just twice, or whatever it is, okay? All right, let's take a look at example 1. It says a pet store sells aquariums in 3 shapes, hexagon, pentagon, and rectangle, and 2 sizes, 10 gallons and 20 gallons. How many different fish tanks can be made from the different shapes and sizes? All right, so for this one, let's kind of make a little chart here for this one. All right, so first of all, we can have the hexagon, we can do the pentagon, or we can do the rectangle. Okay, then there's 2 sizes, so I can have a 10 and a 20. Okay, so then how many different outcomes would there be for this one? In this case, we would have H10, H20, P10, P20, R10, and R20. So that means there are 6 different ones. So we're just counting up the bottom row here. So there are 6 different tanks. And that's it, okay? All right, let's try the next one. Okay, go ahead and try the got it question by yourself. And let's take a look. So it says Miranda has 5 shirts and 4 pairs of pants that she uses for her work clothes. How many different outfits can be assembled using 5 shirts and 4 pairs of pants? Okay, so we're going to call this shirt 1, shirt 2, shirt 3, shirt 4, shirt 5. Okay, and then from there we all get 4 pairs of pants. All right, so we're just going to do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, so what we have is we have 4 sets of 5. Or 5 sets of 4, We have 5 sets of 4, so that means there would be 20 outcomes then. So we have 20 different outfits. And there we go. All right. So obviously you probably have already figured out basically what you're going to do is take the one outcome, the number of outcomes that one has, and the other number, and then you just multiply those together. Okay? So that's the really easy way to do it. All right, let's take a look at example 2. It says students are assigned a temporary password for the first time they visit the computer lab. Temporary passwords consist of a letter A, B, or C, followed by a number, 1 or 2, followed by a letter X, Y, or Z. How many different temporary passwords are there? Okay, so let's try it a little bit easier this time. So we know that there are 3 letters at the beginning, so we'd have 3. Then we have a choice of 2 numbers, so that would be times 2. And then we have another set of 3 letters, so that would be times 3. All right, so we have 3 times 2, which would be 6. 6 times 3, which would be 18. So altogether we have 18 different passwords. Okay. All right, let's try the Got It question by ourselves. All right, it says, a pizza shop has regular, deep dish, and thin crust, 2 different cheeses, and 5 different toppings. How many different 1 cheese and 1 topping pizzas can be ordered? All right, so we have regular, deep, and thin, so there's 3 types of crusts. There's 2 different types of cheeses, so that's times 2 then. And then we have 5 toppings, so that's times 5. So 3 times 2 times 5, so that's 6, and then times 5 would be 30. So we have 30 different pizzas. All right. All right, let's go ahead and turn the page. All right, example 3 says, Emilio has 2 counters. Each counter has one side marked with an E and the other side marked with a J for Jacob. Both counters are tossed. If one counter lands with E up and the other lands with J up, Emilio wins. Otherwise, Jacob wins. What's the probability that Emilio will win? All right, so for this one, we need to first find the number of outcomes. So we could end up with EE, EJ, and then JE, or JJ. Okay? So that means there's 4 different outcomes. And then we need to figure out how many times Emilio can actually win. It says if one counter lands with an E up and the other lands with a J up, so you have to have one of each letter, then Emilio wins. Otherwise, Jacob wins. So it looks like there'd be 2 out of the 4. So 2 out of 4 ways, which would be 1/2. Okay, so the probability of him winning is 1/2 of the time. All right, number 3 on the Got It question. All right, go ahead and pause it and try this one. And let's take a look. So it says, what is the probability of randomly choosing a 5-letter password that consists of only vowels if each vowel can be used more than once? Okay, so for this one, we're going to have, there's 5 vowels, A, E, I, O, and U. So we can use all 5 every single time, and we need to do it 5 times. So we're going to have 5 times 5 times 5 times 5 times 5. So we have a group of 25 here, a group of 25 here. We have 25 and 25, which is 625. And then we're going to do 625 times 5. Okay, so that's going to be 25. Carry the 2, that'd be 10, 12. Carry the 1, 30 plus 1 will be 31. So there's 3,125 ways that it can happen, and we're doing probability, so we only get to choose 1 out of that many, so the probability is going to be 1 over 3,125. Okay? Again, we're finding probability, so you use a fraction. Okay, when you do outcomes, you use whole numbers. So this time we need a fraction. All right, let's take a look at number 4. It says Lamar is going to spin each spinner once. What is the probability that he will spin red and the number 9? Okay, so let's take a look. So again, we're looking for probability. So he first has to spin red. So how many ways can he spin red on the first spinner? Well, there's only one segment, so that's what we have. So it's going to be 1 out of. And then how many segments do we have? 1, 2, 3, 4, 5. So he has a 1 in 5 chance the first time. Now, when you do multiple events, sorry, lost my train of thought, multiple events, you're going to multiply in the middle. Multiple events, multiply the results together. All right. Then he has to also spin a 9. All right. Well, there's only one segment up there that has a 9 on it. And there are 10 segments. So we're going to have a 1 in 10 chance every time. All right. So then when we multiply, remember we multiply across the top. So 1 times 1 is 1. And then 5 times 10 would make it 50. So he only has a 1 in 50 shot, okay, of actually getting it. Okay, so 1/50th of the time. So one spin out of 50 times, he'll probably get it. All right. Okay, let's try the got it question by ourselves. And let's take a look. It says 3 number cubes are rolled. What's the probability of rolling 3 5s? Okay, well, on a number cube, you have 1, 2, 3, 4, 5, 6. Okay, we need to roll 5 each time. So we get a 1 in 6 chance the first time. We're doing it 3 times, so we're going to have a 1 in 6 chance again. And then a 1 in 6 chance again. So we have 1 times 1 times 1, which is 1, of course. 6 times 6, which is 36. And then we have 36 times 6. And it's 216. So it's 1 over 216. All right. And that's it. Thanks for watching. Give me a like and subscribe if you haven't already. And thanks for watching. I'll see you next time.